Hello! In the video you're about to watch, we're going to look at the relationship between population trends and development. We're also going to look at two graphic devices that geographers can use to analyze a population. A rapidly growing population can have a profound impact on a country. It might lead to starvation, economic depression, or even political instability as the government struggles to handle all the new mouths it has to feed. On the other hand, a rapidly shrinking population is a problem as well. The population will begin to age and lack the youth needed to continue to support the country. Whether a country's population is growing or shrinking has a huge effect on the country and its development. So if population has such a big effect, can we predict changes in population growth in order to prepare for them? All countries tend to experience similar changes to their population over time and as they develop. While not all countries follow the pattern exactly, the demographic transition model is a useful tool for analyzing a country's population and development. The demographic transition model shows the interaction between three variables over time: birth rate, death rate, and the rate of natural increase. Birth rate is the number of births per 1,000 people a country has per year. It is not a percentage, and it is not a total number of births. If a country's birth rate is 66, that means for every 1,000 people in a country, 66 babies are born in a particular year. Death rate is a similar statistic. It is the number of deaths per 1,000 people in a year. When you combine birth rate and death rate, you get the country's rate of natural increase. If a country has a birth rate of 66 and a death rate of 25, then its rate of natural increase would be 41. We can convert that to a percentage by moving the decimal place to the left by 1. That would give the country a natural increase percentage of 4.1%. Whoa, that's a lot of growth. To compare, the world's current rate of natural increase is approximately 1.2%. This is lower than our rate of natural increase in the mid-1900s when it reached 2.2% in 1963. So now that you know what it's measuring, let's look at the DTM. The demographic transition splits societies into 4 stages, as well as a possible 5th stage. In the first stage of the DTM, we see the kind of society that has typified much of human history, going back thousands of years. This society has a very high birth rate and a very high death rate. While the birth and death rates vary, the end result is a rate of natural increase that is very low, as the two tend to cancel each other out. A moderate amount of growth might take place in stage 1, but overall, natural increase is low. When a country moves into stage 2 of the DTM, it experiences an extremely rapid drop in the death rate. This could be due to improvements in sanitation, healthcare, or food and water supplies. The birth rate remains high, and the end result is a huge population boom. As the country continues to develop, it moves into stage 3. During stage 3, the birth rate begins to decline along with the death rate. The result is a slow growth rate overall. People's standard of living tends to increase, they live longer, and children are no longer seen as a necessity. Finally, when a country reaches the highest levels of development, it enters stage 4 of the demographic transition model. Birth rate drops to match the death rate. The rate of natural increase approaches 0, which is referred to quite obviously as zero population growth. There are no longer enough children born to replace adults as they die, and a country's population may actually begin to shrink. This shrinking population stage is sometimes referred to as stage 5 on the DTM. Few, if any, countries are actually in stage 5, however, so for now it is merely a possible stage instead of one that we've observed in history. The DTM is in some ways a cycle. The rate of natural increase in stage 1 looks a lot like the rate of natural increase in stage 4. However, the birth rate and death rate in stage 4 is much lower, and the overall population of the country in stage 4 is higher than it was in stage 1. So how can we tell what stage of the demographic transition model a country is in? One very useful tool for analyzing a country's population is a population pyramid. Population pyramid is a graphic device that demonstrates the structure of a country's population. It does so by displaying age and gender groups on a 2-sided bar graph. One side of the bar graph shows female population, the other shows male population. Each bar displays an age group, starting with the youngest at the bottom. Some population pyramids show this number as a percentage, others show total population at each age group. Either way, the shape of the population pyramid shows us a lot about that country's population. To analyze a population pyramid, always start at the bottom. If the bottom of the pyramid is wider than everything else, then the country has a very high birth rate. If the size of each bar shrinks rapidly and ends in a very sharp point, then the country also has a very high death rate. If, on the other hand, the decrease is slight, or the bottom is actually smaller than the middle, then the country has a lower birth rate, and its birth rate might even be lower than its death rate. As you look up to the older ages on the population pyramid, you can also tell relatively how long people live. The thicker the top of the pyramid, the higher the life expectancy. So to wrap it up, the amount of population growth a country has really affects conditions for people living there. Two tools for predicting and analyzing a country's population growth are the demographic transition model and population pyramids. As you study population geography around the world, these two tools will be handy. Population pyramids tell us about a country's current and historic population, and the DTM allows us to use those population pyramids to figure out how developed the country might be.